chapter 18 today. Start 19 is going to be our major goal, and then Tuesday we're going to look at finishing up chapter 19. Part of chapter 19 is like a no-brainer. It's artery, vein, capillary anatomy or structure. But the other part of this chapter is blood pressure, fluid electrolyte balance, capillary exchange, and that's some heavy-duty stuff. What I'm afraid of is if I cover that information on Tuesday on capillary exchange and pressure, and then turn around and 48 hours later pop you with a test, your brain will explode. So what I was thinking of is doing this. Instead of giving you the exam on Thursday the 24th, is actually go ahead and move it to the 1st of March. That will give you an extra cushion there. Give you time to go home and let the info stew in your brain. But what that means is we'd have to actually go ahead and look at, I think it's respiratory system is the next chapter. We'd go ahead and start that chapter, but in the meantime at home you'll be looking over your capillary exchange and all that fluid stuff. Would you rather do it that way, or do you want to just go ahead, learn it, and take the test, and then keep on moving? You want the cushion day built in? Okay. Most of you agree with that?
Yeah, we're already working on the respiratory system now.
Okay, so this will kind of get you caught a little bit back up. Now, if anybody doesn't like this, you're absolutely welcome to come get the test taken with me early. I have it made out.
Don't hold your breath.
Yeah, really. I'll have my door open for you if you'd like to come by. But no, seriously, if you feel ready and you don't want to get confused by hearing the respiratory, you're absolutely welcome to come on and take it with me early. But I wanted to give you a weekend time period to get this material stuck in your brain. So that means we will cover our last bit from chapter 19 on this coming Tuesday. Next Thursday, we'll cover a little bit of the respiratory system. I can certainly do questions on chapter 19, and then that'll mean the following Tuesday will be your exam. Okay.
Thank you.
Sure. Any questions about that schedule?
It has on chapter 18.
18, 19, yeah.
Yeah, I changed my mind. I have to take it Monday.
Maybe the next Monday. I wanted to ask you all if you had any questions from chapter 18. There was a page I wanted y'all to read over on heart attack and angina. So, Kenya, go ahead and start with your question.
If you can just go over page 49, the regulation of the heart rate.
Which part? Okay. Okay. Let's start with factors that increase heart rate and talk about the ions that are listed there. First off, it says hypercalcemia. So let's take a look on that picture. You might recall from hearing in Bio 210 the role of calcium in the muscle contraction. In order for a muscle to contract, and cardiac muscle is pretty much the same in terms of skeletal muscle contraction, calcium has to enter into the cell. You might recall this troponin-tropomyosin complex. It acts as a blindfold to hide the actin binding site. When calcium binds to troponin and tropomyosin, it will actually pull that blindfold up and out of the way, now exposing those binding sites. Now that the binding sites are exposed, what happens next? Muscle contraction, good. What can attach to those binding sites? Myosin heads, good. So in the term here of hypercalcemia, if you have excess blood calcium, that increases the rate at which we can expose those binding sites and allow those myosin heads to power stroke and attach to those actin filaments. That's going to actually increase the heart rate. So the bottom line, excess blood calcium is not necessarily a good thing. It can increase heart rate by exposing more of those binding sites more quickly, increasing the amount of myosin heads that can attach and pull and promote that contraction. Okay, that's one thing we're looking at. The second thing we're looking at is called hypokalemia. Hypokalemia is low levels of what? Potassium. Okay. Notice it says there that things like Lasix, a diuretic, vomiting, diarrhea, excess perspiration can deplete your levels of potassium. Where is potassium normally found? Inside your cell. Muscle cells and nerve cells at rest expect to have a certain amount of potassium ions inside. That is what we're looking at here. We're looking at a number of these potassium ions in here to maintain the resting potential, something around a negative 70 millivolt charge. Alright, with hypokalemia, you may have less of these inside. What does that do for your chances of staying at rest? Well, let's see. If the inside has to be negative in relation to the outside being positive, let's say I take away a handful of those potassium ions. Instead of being negative 70 millivolts now, I may only be negative 50, negative 40 millivolts. Am I staying at rest like I need to? Probably not. So my chances for reaching action potential are even better. So it makes it easier for us to reach action potential, harder for us to stay at rest if you have low potassium levels. So you'll notice here that low potassium levels actually make the heart beat feebly and arrhythmically. So if you don't have enough potassium in here to maintain rest, then it makes it a little easier for it to tip over to the positive side and actually get over there into reaching an action potential. Does this make sense so far? Okay, any questions so far? Alright, this is really going entirely back. I believe this was chapter 11 in Bio 210. So you might at this point want to go back and review chapter 11, get all that stuff about sodium, potassium, and calcium, and the roles in their maintenance of a resting potential or an action potential. To flip-flop the scenario here, let's take a look at the bottom of your page with the ions down there. These are factors that decrease heart rate. If you decrease heart rate, you decrease cardiac output. You also decrease what else?
Volume.
Stroke volume, good. So we're looking right now at decreasing heart rate. So you'll notice their first ion listed is calcium again. Hypocalcemia is low calcium levels in the bloodstream. Let's go back to this picture again. What is calcium responsible for doing? Good. Exposing those binding sites, it binds to troponin and tropomyosin, it lifts them up and out of the way, exposing those little binding sites that you can see there. Once those binding sites are exposed, myosin heads can do the power stroke, attach to those binding sites, and then pull those muscles, promoting a muscle contraction. Alright, so here's the flip side of the coin. If you don't have enough calcium available to flip up those binding sites and expose them, then what does that mean for your chances of a muscle contraction?
Not good.
Not good. Probably not going to happen. So we're looking at a problem here with getting muscles to contract. Notice that hypocalcemia depresses the heart rate. And this is why we're not able to get the power stroke, the action potential, all that good stuff going on here, so that we can actually promote the muscle to contract. Alright, so it is absolutely opposite from hypercalcemia. Hypocalcemia does the exact opposite in terms of heart rate. What did hypokalemia, low potassium levels, do to the heart rate? Increased it. Low potassium levels increased heart rate. Okay, so we just talked about that when there makes the heart beat feebly and arrhythmically. We made that resting potential not quite as negative as it needs to be, so it made it a little easier for that heart to actually reach action potential. Flip the coin. Go ahead, Hannah.
So you said that hypokalemia makes the heart beat faster?
Technically faster because it makes the action potential easier to reach. And they say here it makes it beat feebly and arrhythmically, so you might not have a regular strong rhythm. It may be faster than what you may expect, maybe something like VTAC.
But you need it in the cell to rest too, right?
Right. It's Goldilocks. You can't have too much, you can't have too little, you gotta have just right. Yeah. Okay, so if low potassium levels do something to increase heart rate, what do high potassium levels do?
Oh, decrease.
Decrease, yeah, flip the coin, this is the other side of the coin. Now let's go back to our resting membrane potential. At rest,